Okay, we're going to carry on with adding fractions. So this time we've got a little bit more abstract. We've got 3/4 of a kilogram of rice in a container. Find the weight of the rice in the container after another 1/2 kilogram is added. Before we get ourselves too confused, or I guess maybe even just stressed about this problem, they made the problem seem more complicated because they've added in a unit of measurement, kilograms, and they've changed the wording. They haven't said add, they said after another 1/2 kilogram is added. But actually, we're talking about the same thing, aren't we? We're talking about 3/4 of a whole. In this case, the whole is a kilogram, and a 1/2 of a whole. In this case, the whole is the kilogram. So actually, it's no different to what we were doing yesterday, but it has been put into a real life problem, and the words make it seem more tricky than it is. We're still talking about 3/4 plus a 1/2. And we know lots about this because we know that 1/2 is the same as 2/4. So 3/4 plus 1/2 is the same as 3/4 plus 2/4, which gives us 5/4. If you think back to the first sections we did on fractions, 5/4 we know is an improper fraction because the numerator is greater than the denominator. So to simplify this down, we would say 1 and 1/4. It's 1/2 because 1/2 is 4/4. We have 5/4. So we've taken those 4/4, changed that to a whole, leaving us with a remainder, if you like, of 1/4. Find the sum of 2/3 and 4/9. Pause the video and see if you can figure this one out. We've got a couple of We've got a couple of clues. Are the denominators the same? Is it an improper fraction? Is it in its simplest form? So we've got to start thinking here. 2/3, that's a proper fraction. Can I simplify it down? Not really. 4/9, that's an improper fraction. Sorry, a proper fraction. Can I simplify it down? Not really. So what do I need to do? I now need to get the denominators being the same. Well, I've already said that I can't easily reduce 9ths to 3rds, but I can make 3rds into 9ths. So 2/3 is going to be the same as how many 9ths? Well, to get my 3rds into 9ths, I've got to cut each of those 3rds into 3 parts. So let's just remind ourselves what I mean. I've got my whole, and my whole is already, let's just pretend these are perfectly equal. They're probably not going to be because I'm drawing them, but I've got my 3rd. To make this into 9ths, I've got to split each of these into 3 parts. 1/3 becomes 3 parts. 1/3 becomes 3 parts. 1/3 becomes 3 parts. Now that is 9ths. So 2/3 was times by 3. So 2 times by 3 is 6. And let's just look at that. I've got 1, 2, 3, 4, 5, 6 9ths. So let's see if I can draw neatly. 2, I can't draw neatly, but is the same as 6 9ths. So now we can do 6 9ths plus 4 9ths equals what? Well, the 9 is the same. The 9 is the same, so 6 plus 4 is 10. What now? 10/9. Does that make sense? Yeah, it makes sense. It's an improper fraction. So I could also simplify it down and write it as 1 and 1/9. Brilliant. Okay, let's just get rid of the pen. What about, we're just going to do, let's do A actually. So 3/4 plus 5/8. Brilliant. Hopefully you've seen that the easiest thing we can do is to split our fourths into 2 parts. So we get 8, so we're doubling 4 and we're doubling 3. So we're talking about 6/8 plus 5/8. So 6/8 plus 5/8. I know these are massive, but bear with me. In fact, I'm not going to draw these out because it's just a pain. 6/8 plus 5/8. Well, actually, we know that the 8s is staying the same, so we don't need to worry about that so much. The 8 is going to be my numerator, but I have got 6 plus 5. What's 6 plus 5? It's 11. 11/8. Can you simplify that down into an improper fraction? 1 3/8. Okay, what about 3/4 and 3/8? It's the same premise, isn't it? We're going to have to change our quarters into 8s. We do that by doubling the number of parts from 4 to 8, multiplying by 2, doubling the numerator by timesing it by 2. So again, it's 6/8 plus 3/8. The 8s remain the same. We're now talking about 6 plus 3, 9, 9/8, or 1 and 1/8. Have a try at C and D for me. If you haven't paused the video, you're going to need to pause the video to give it a try. Brilliant. So we're going to do the same thing, 5 and 10ths, 5ths and 10ths. We're going to multiply this by 2 to get twice as many parts, which means we multiply the numerator. So we're talking about 3/5 being the same as 6/10. It's the same as 6/10. 6/10 plus 7/10 is 13/10, or 1 3/10. Same thing here, 4/5 and 3/10. We're going to change our 4/5 into tenths. And we know that the way we do that is by multiplying the 5 by 2, because 5 times 2 makes 10. So that's going to become 8/10 and 3/10. In fact, did we have that one already? No. 8/10 plus 3/10. 8 plus 3 is 11, 11/10, or 1 1/10. So the trick with these questions is always making the denominator the same. What is the relationship between these denominators? And in all of these ones, it's been nice and simple. It's been doubling. Might not be a doubling. It might be timesing by 3 or times by 4. It does rely on your times table knowledge. So in this case, we're doubling, but it won't necessarily always be doubling. Can you try worksheet 10? The link is on the PDF for today. Once you finish it, just like every other time, come back, check your answers. Brilliant. So worksheet 10, here are the answers. Again, if you made a mistake changing from the improper to the mixed fraction, from the improper to the mixed, that's fine. Although I would like to go back to the first week of fractions and just double check if you're making a mistake. Have a look at those videos again if need be. Have a look at your worksheets again. If we're making a mistake on that, let's try and work out what the mistake is, because you don't want to keep repeating that mistake. And again, I'm not worried if you didn't follow the exact method that they used, as long as you've come to the same answer. Brilliant. And that is the end of today's lesson. We are going to do one more lesson of fractions this week. We're not going to do our normal calculations lesson for this week, because I want to just get to the end of adding fractions so that next week we can move on to subtraction.